Hello, my name is Beda Hammerschmidt, and today I will talk about how you can use JSON for modern application development. I will show a lot of things that you can do today with Oracle Database, but I will also talk a bit about what's coming in the future. And for that reason, I've put up this safe harbor statement slide. So I joined Oracle in 2006. For the most time, I was a developer. I worked on XML and on JSON. So some of the features you'll see today, I implemented them. But since a year or two, I'm now a development manager, but I'm on the same team. So let's get started and see what's good today. So the big message really is what we try to do at Oracle is we try to combine the power of SQL with the flexibility of JSON. And let's look at what this really means. So our database, the Oracle database, as you know, is obviously capable to store tables and columns and rows, but it can do a lot more. So it is really a converged database where you have support for various data models, like JSON is one of them, or XML, or full text search and graph. And the reason our customers really like that is that they can run all their workload types in one database architecture. It doesn't mean that it's all stored in the same database, but it's on the same database technology, meaning it's the same consistency model, the same security model, etc. So the skills can really be reused across different workloads type. The other thing is what we try not to do, or what we recommend our customers not to do, is to use like a zoo of special purpose databases that all use different query languages. This is what you see here on the right side, where data sits in one database but needs to be processed in another. So this typically leads to a lot of chaos if you want to run workloads across different databases. So Converged database makes it a lot easier, and we're focusing on the JSON aspect of it. So JSON, as you know, is a schema-flexible data model. So unlike the relational model where you have to upfront design your schema, you specify which tables you have, the columns, the data types, etc. So before your application can store any data, you have to really think about normalization and database schema. And this is a lot easier with JSON, which is a simple format consisting of these key value pairs, and you do not have to define an upfront schema, which also means that if your application changes, for example, you have a new field, you can simply add this to the JSON and your database continues to work with it. This is one benefit, the schema flexibility. Another benefit is really that JSON can easily be consumed by various applications or programming languages. Especially it means if you're thinking in objects, like object-oriented, like Java, for example, you can very easily map your classes to JSON representations and vice versa. So there is no impedance mismatch of mapping your, let's say, Java objects to multiple tables. Instead, you map it to one JSON. Also optimizes your read and write performance because you may not have to do a lot of join in this case. And the other aspect is that it is supported widely. There is different APIs. It's human readable. And this really makes JSON these days a very widely used format. So what we try to do is give our users who store JSON in the database really the full flexibility of working with it. So this means on one side, what we see here on the right side, we want to do analytical queries over JSON or reporting. And for that, we want to use SQL. And we would map, we're going to see this in the demo, we will make JSON accessible to SQL so that you can work with it like you would do it today with your relational data. But on the other hand, for application development, people often prefer simpler APIs where they don't want to write SQL for simple CRUB operations. Instead, they want to do like a simple put or get or delete command, or they want to find documents based on some criteria. So to these folks, the data really looks like objects. The application developers work with objects, whereas, let's say, data analysts, etc., they look at data as rows and columns. And we want to give both these groups the ability to work with the JSON in their preferred format and not have to replicate data across different databases. databases. And in today's demo, we look here especially on the MongoDB API. So for people who like to use MongoDB, they can do that with Oracle Database, while at the same time, they will now be able to run SQL over the data. So I skipped the slide. Let's go back. So before we really get started with the demo, the most part of this presentation is really the demo, but I guess a lot of you will be familiar with Oracle and you know how to store data in a relational model or in a table. So a quick example here, how you could store JSON in a table. So it is nothing more than just a column data type. So here you see a table, it's called movies, and you have some columns and their data type. So this will all look very familiar to you. But then if I wanted to store some JSON, well, all I do is I add an extra column or maybe multiple columns, and this is where my JSON lives in. So this could become very handy, for example, as a flex field. Let's say I want to map some new fields to that JSON instead of having to add columns as my application evolves. So my relational data and my JSON data can really live happily alongside. It's not an either or choice. It can be really a combination of both. And I can choose how many of these values I want to store in my JSON or as relational columns. So it's very easy to get started, to store it. And now I want to show you some examples on this Converged database, where I basically have one model and go to the other. We will see more in the demo, how to simply query it, but this is really explaining how we can map things. So assume that you have stored a JSON document in your movies table. So we have these key value pairs, like title has the value alien, etc. But then because it's JSON, you can arbitrarily nest these key value pairs. So for example, crew is not a single scalar value. Instead, it's a JSON array, or think of a list of values. And inside this JSON array, we have nested JSON objects, and they again have key value pairs. And again, there could be an array down here. So this is how a JSON hierarchy would look like. And we can make this accessible to SQL by just mapping selected values to columns. So the way this works is I have these path expressions, for example, movie ID, which I map to a column called ID. So here you would say there is an ID column and there is a path expression. And by the way, $, doesn't mean that you have to pay Oracle extra money. That is just like the variable for the current context node, which happens to be the document here. So with .movie ID, I navigate to this value 200, and this is where you see the value 200. By the way, the syntax here will look very familiar for those of you that use JavaScript. So if we look at the next example, like the crew, $.crew, and then square bracket, and then we have the star inside. This basically means iterate over each of these objects in this crew array, and then project out further columns. For example, the job. And you will see here that these nested values, producer, director, screenwriter, are just being returned as separate column or row values here. And this way, we can really flatten the data. We can really make it fully accessible to a relational system. So at this point, I could run arbitrary SQL over this JSON data. And this is what we're going to see in the demo in a more concrete example. So the other direction would also be possible. Let's say I have an existing application that uses tables, nothing JSON, plain old relational data. And I want to, for example, create a microservice over this data, which exposes the values as JSON. Well, I can just use SQL. So this is an example where I query my customers table, and then I select the name of the customer, or I build an object. You see, I construct an object which has a field name, and this is the concatenation of the first and the last, and this generates this key value pair here. I have another key called movies, and you see this here, and the value is a subquery which selects all the titles from the watched view. So you see we have like a SQL join here between movies and watches, and this gives us the titles of the movies that this person has watched. So at the end, it is like a fully conventional SQL statement that selects from table, that does join, and all I do is I add a bit of JSON constructors to that, and this will return now the value as a JSON document per row. Good, so now we understand how JSON can be stored in a relational database and how you can use SQL to query or to generate it. Now we want to look at JSON collections. This is a concept that NoSQL databases like MongoDB have introduced, and our JSON collections are MongoDB compatible. So it's really just a different way to look at your data. So on the conceptual model, you don't work with tables, but instead you will work with JSON collections. And because these are MongoDB compatible, it allows a developer who has experience with MongoDB or wants to use some of the drivers to continue to use this with Oracle. So this allows basically the also to run SQL over the data that otherwise in MongoDB wouldn't be possible, but it also allows to just migrate some applications to Oracle because the drivers, the tools, the skills, etc., can continue to be you can continue to use them. Good. So let's look at an example here just to explain this, how this conceptually works. So we have a simple program here on the right side. We basically connect to a database using a connect string. Then we get a database called admin. We create a collection called employees. We insert some JSON data. So it's probably some employee data that we insert as a JSON. So there is no schema definition, etc. And if we've inserted many employees, maybe we want to find all the people where the job is a programmer. So I have a filter here, which has this key value pair, job being programmer, and then I invoke a find method, and then I iterate over the query result. So if we look at this concept, there is the document. This is basically some JSON data, which is typically schema flexible. So I don't have to declare what the key value pairs are or what their data types are. And these documents live inside a collection. So collection is kind of a bag of JSON. It has a name, but that's pretty much all it has. So here we call this bag of JSON or collection employees. And then the database maintains a set of these collections. So I could say my, I don't know, employee database has employees and maybe another collection on, I don't know, rewards whatsoever, but then my application lives with database, collection, and document. And I can use that without ever having to write a single line of SQL, because for simple operations like find or filter or insert, there are implementations directly in my programming language. So it's like Java, I just do a insert one and insert my data, or I do a collection find. So it's very short, it's very readable. But if we look at it a bit more closely, we can actually map this conceptual world very nicely to the relational model that we have in Oracle. So we can say, well, what MongoDB calls a database is really what we call a schema. So there is no mismatch there. And similarly, what's a collection is what we call a table. So usually the user tells us how a table looks like, but what we're going to see is that if the user says, I want to have a collection that stores JSON, we can automatically create the corresponding table. And in the simplest case, it would just be a table with two columns, the ID and the data as JSON, and this can perfectly serve as a JSON collection. And if we look at a single document, like which we insert here, well, that's a row into the table. So it's kind of like an insert statement in SQL. And if we do a filter expression, that's what we typically call a query. And this is exactly what we're going to do in our Mongo API, that if the user connects from a Mongo tool or driver and they issue these commands, we will automatically run the equivalent SQL command that is needed to execute this operation. Perfect. And with this, let's actually take a look at how this behaves in reality. And let's do a demo now. I use the autonomous database for this demo.
And as you can see, I'm using a free tier account. So everything I show here, you can also do if you have an always free tier account. And if you don't have one, it's very easy to sign up. I'm using the 19C version. That is also one, if you use an on-premise installation of Oracle, you likely will have a 19C version. So you can also do the steps that I do here using your your on-premise database. So if I click on database action, I see important information on how to connect to my database. And we're mostly interested in the Mongo connect string because we want to work with JSON. And I want to show how you can work with JSON in Oracle database using various APIs and SQL. And one of the APIs is the MongoDB API. So here I'm getting the information on how to connect to it. And I also get the UIs if I want to work with SQL or with JSON. So let's just quickly click on JSON here. And there is a tutorial starting. I abort it by clicking on it X. But basically, this shows us the JSON collections here. There is nothing. We're starting with an empty database. So let's load some data. And I want to use the Oracle database like I would use a MongoDB. So I'm starting a tool here called Mongo Shell. And this is not an Oracle tool. That's a tool provided by MongoDB. And I can show the collections that are in the database. And you see there are none. This is an empty database. And I'm creating a collection. And the way I created this is interesting in MongoDB. So you don't have to like create a collection separately as you would create a table in a relational database. What you do instead is you just insert some JSON and you insert that to a collection. Here it's called test123. And if this collection does not exist, it gets auto-created. So if I repeat my show collections command, we now see there is a collection called test123. I also don't have to define any schema. So this is the case with JSON, that very often you work with JSON and you don't want to define, or you cannot define an upfront schema, and your data may change. So for example, here, the first document I inserted was a movie, and a movie may have certain fields. And now the second document I'm inserting, this is a book, and the book has other fields like author, for example. Author didn't exist for the movie. So this is no problem with JSON, where I can just insert these documents. Now, in order to work with this, I need to basically find the documents I'm interested in, and MongoDB has a query language which is not SQL. Instead, it's using JSON as a filter language. So here I'm interested in all the movies which have a field type, and the corresponding value would be movie. And you see that the one document, the one movie we inserted, got selected. That's not a big surprise. Let's filter on let's use another filter here where the price is less than 10. So $LT means less than 10. And this now selects both of our documents. So this just shows how with Mongo Shell, I can insert data into MongoDB database, or in this case, we're actually used it to insert data into an Oracle database. So now I click the refresh button. We see this collection test123 shows up, and the data that I just inserted through this Mongo tool is also available in this JSON page. So the JSON page is like a UI to make working with JSON easy in Oracle. So I can use the same filter expressions that I used with MongoDB. I can say, well, find me all the movies or find me all the documents where the type is movie. It gives us this movie. It's the same result we've seen before. Now it's just run on Oracle here at the price less than 10. This selects us the book and the movie. Good. So let's load a bit more data, because just working with two documents is not so much fun, but I don't want to like using this tool because it's very slow. Instead, I use another tool from MongoDB, which is called Compass. This is their visual tool. So I connect to the same Oracle database, and I forgot to click on the connect button, so I'm connecting to it. And we see that in that admin user or admin schema, we have our test123 collection, but I want to create another collection from this tool, and I want to call it movies. So I create a collection, and I click here on movies, and then I add some data, and I'm doing an import. So there is a movies.json, which has a bit more data, and I can just use this. Again, MongoDB tools. If I'm a developer who likes to use MongoDB tools or drivers, etc., I can just continue using them, even if the data is stored in an Oracle database. So now the data should have been loaded. If I click here on the refresh button, there is a collection called movies, and we see that there is more data inside, so we can run this. Run some interesting queries. I could also run this on the Mongo shell. So now I'm selected from the movies collection, and I want to find out which are all the movies where the price is less than that 3.1. This gives us Casino and Princess Bride, and I can run the same query here. Obviously, I only need the JSON part of the query in the search box, and we see the same result got loaded. Good. So these filter expressions so far looked very simple. I only filtered on a single field and did like a quality, or in this case, a range query, but this can get arbitrarily complex. This is an example where I want to filter on two conditions. So I combine them with an and I want to see whether the price is less than 5. And the genre is science fiction, or it contains science fiction. And we see, for example, Interstellar is selected. And the genre here contains the value sci-fi. So in this query language, or in this filter language, if a value or if a field is an array, then we basically compare that filter condition with every item of the array. So genre does not have to be sci-fi, but if it's an array and it contains sci-fi, it's only satisfied. And this makes cardinality changes quite easy. So whether you have one genre or multiple, it's the same query that you can issue on that data. It's also possible to use REST to access the data. So far, I've shown you like the JSON page and Compass, or the Mongo API, Mongo shell. If I want, I could also use REST. So you see, I'm also selecting here from Oracle Clouds, and I see all the collections that exist. So there's the movies collection, and there's the test123. So if I want to look into a specific collection, I can just add movies here. And here I see all the values inside this collection. So these are all the movies. And if I'm interested in one, I can just add the ID here. So 338 is the movie Dr. Strangelove that I actually watched quite recently, and I really liked it. So now we kind of covered that I can access my data using Mongo API and REST here. I could also use REST for updates. I would use that with curl, like the browser can only do get commands, but I think you get the message here. Now let's look at this SQL side. So I will leave this JSON page now. So the JSON page gives me access to JSON as a collection. So a collection is basically just a bag of JSONs, and it has a name like movies or test123. And how does this look like if I just change to the SQL view of this? So now we see that our collections are also tables. And I didn't have to specify how these tables look like. I didn't have to specify the column names or the data types. Instead, these tables were generated and when we said we wanted to have a collection. So the way we store the JSON is that we store them in a column or in a blob. It's called data, and we use a binary encoding here. We call that OSIN. It's very efficient for piecewise updates and also for fast queries, because we can jump to values that we're interested in. Then this data contains the document. It's associated with an ID. So for ID lookups, I can just very quickly use an index on the ID column. And then there is like some bookkeeping columns when a document was created or updated, or a version for optimistic locking, etc. So if I wanted to see this data in SQL, It's stored in a blob. So I use JSON serialize to convert it back to a textual representation. And you can see here that the data we inserted through MongoDB Compass also is accessible through a simple select from statement in SQL. So the data is here, but I can also look inside it. So it's not only that this is just like a JSON payload and I have to kind of treat it always as one big unit. No, that's not the case. I can really look inside of it. So I can basically select this column where the JSON is inside, and then I can use .title or .price, etc., to really extract the data from it. So here you see we extracted the title, the price. It really looks like a relational output at this point. And it's not only that I can use these in the select list, I could also use them in the from clause or in the where clause. So here you see I'm filtering the documents on the title, where the title contains the word strange somewhere. And you see there's two movies where we have the word strangers. This is the one movie we've seen here with the ID 338. Okay, let's make a quick update here so that you really see that the data is stored in Oracle before we go into like more query capabilities. So I'm running a very simple update statement. So I'm updating the one document where the ID is 338. I use this SQL JSON operator JSON transform, which allows me to make changes to my JSON data. And what I'm doing here is quite simple. So I'm setting the price to 15. The price is right now $9.59. I watched the movie. I liked it. I think it's worth at least 15 here. And I'm also adding a new field here called note. And the value is like great movie. So JSON is schema-less. I can very easily add a new field as I go. So I make this update. I see one row got updated. And I refresh this using REST. And just reload this. You see 15, great movie. It got updated. And I could also come from the Mongo API here and say, I want to find inside my movies collections the movie where the ID is 338. And you see the price got updated to 15. And this node is also present. So not only can I make changes from Mongo and read them from the database, I can also make changes here in SQL and read them from REST or the Mongo API. It's basically the full cycle that's possible. Now, let's step back a second. Very often, if you want to run analytical queries or reports over your JSON data, you have to understand how your data looks like. So if you're the application developer who created the JSON, it might be very simple. But if you are like a data analyst or a DBA, etc., who has not created the JSON, then you first need to understand how your JSON looks like. And again, because JSON does not have a schema, there is no formal declaration of the field names and the data types, etc., that exist in your JSON. So what we provide here is another SQL operator called JSON Data Guide. And it scans the data and gives a summary of all the field names that occur in your entire data set. So the output is one object, and this is the structural summary of all JSON documents inside. So basically, it tells the JSON data guide tells us we're looking at an object, and it has the following field names or called properties here. There is like an underscore ID, which is a number. There is the note. This is the field I just added when I made an update to that one movie. I added a new field called note, so it gets detected here, and it tells us it's of data type string, and it would fit in this length. We see there is a field called plot. It's much longer, and so on. So we see all these fields that occur in our data. And the data type could be scalar, like here, the format is a string, or it could say, well, I have some arrays in my data. So for example, genres is really an array. And we have also an array where all the names of the stars are inside. So this gives me already some good understanding of what field names exist and how I could query them. But I can also use this information to auto-generate a view. So what I do now is I take this statement here, this select data guide, and I assign it to a variable called DG. So this is our select data guide. So this is like what we call like a PL SQL block. This is our stored procedure language in the database. I select the data guide, which you still see at the bottom. I assign it to this variable. This is like a temp variable called DG. And then I pass DG into this method, which creates a view. We want to call it like a movies view. It sits on top of our movies collection on the data. And let's run this. And we see this procedure got successfully completed. And if I move here to views, I see that a new view has been created. It calls movie views. And all the top level scalar fields like format, year, type are now accessible as regular view columns. So I could describe this view. And we see that not only these field names are being used as column names, but it also picked the type information from the data guide. So we see that year is relatively short, whereas title can get quite long and the plot can even get longer. So with this, I could select all the values, for example, for a movie like Star Wars. So we see some of these fields are from the collection, like the created on, ID, etc. But if we scroll to the right, we see there is the plot, the type, the year, the price. So it's all becoming easily accessible as regular view columns. So we see, for example, that there is a column called condition. The value is used. Well, what are all the possible values for condition? Well, all I have to do is like select a distinct on condition. And I see in my entire data set, I have 8 different values for condition, like used with scratches or acceptable, whatever. So a simple SQL query gives me that information. I can also run some simple reports. For example, here, I want to group the movies by decade. So in our movies, we have like 70s, 80s, 90s, etc. And I want to count how many I have per decade and order it. So I see I have the most movies from the 2000s, followed by the 90s, etc. Or I could say, well, what is the average price per format? And again, it's just a simple group by with some calculation, average price. And we see we have these 5 different formats. And this is the price per this. So this is quite simple to analyze. But what we want to look at now is how to deal with JSON arrays. So as you know, JSON can have nested structures like nested object, nested arrays, and especially nested arrays allows us to have like multiple values on a per document or per row basis. So if we look here, this is like one row or one document, but inside we have this array called starring. These are the stars of that movie. And you see here we have multiple values. We have Kevin Spacey, etc. So multiple values per document. How can we look inside that? And the simple thing is to use again, like a SQL JSON operator. Here it's called JSON exists. We apply it on our document and we say, well, navigate. This is like a JSON path expression. Dollar is the context. It starts with the entire document. We use dot starring to go to this array. And then there's this question mark, which means I want to run a filter or a predicate expression. And the predicate is compare every value inside the array with this value. And if you find the value, then select the entire row. So if we run this, we see that these 4 movies or these 4 rows or documents are getting selected because they all have an array where Morgan Freeman is a value inside this array. So now this allows us to find the values, but it still doesn't allow us to see these values or these actor names, star names as separate row values. So how can we expand this or flatten this into separate columns? And what we do is here it's basically the operator is called JSON table. Here we have a simplified syntax of it. Let me just run it. That always makes it easier to explain it. So what we do is we go to our movies table And then we expand the JSON from the data. So we say from movies, go to data, and then project out these columns. So you see we named the ID, we get the ID value out, the title is the title, we say the year gets projected out, and then we give the additional information that year is a number. So if I don't specify the data type, it's a string, but I can say that a column is of type number or date or timestamp, etc. And then I get the proper range comparison semantics. So year gets out as a number. Now we go to our array with the stars. The name was starring, and the square bracket star means iterate over all the items in the array and project out a further column. So I use this columns clause recursively. So regardless of how deep my arrays are nested, or if I have arrays of object of arrays, etc., whatever nested structure I have, whatever hierarchy, I can come up with one syntax to recursively unnest this. So now on that nested array, I want to project out another column called actor. And this is the current context node. Again, the symbol is the $, and that is the string inside the array. So what you see then is that we have different rows for these stars, and all the values outside of this array, basically all that stuff here, gets repeated. So the movie American Beauty had 3 different stars. So you see them being listed here on the actor column, and all the rest here gets repeated. So this way, I was really able to flatten the data, really make it look like a relational representation would look like. And then I can very easily also add a where clause here. So if I wanted to find out all the, okay, there's a typo here. Let me just copy the entire statement back to this. If I run it like this, I can also just now filter on a column like this artificial column actor. And I can just use a simple SQL equals to compare it with Morgan Freeman. And now I see all the movies where Morgan Freeman is an actor or a star in. With this, I can also run a simple analytical query. So I want to know how many movies does a star play in. So I'm using the same example here where I unnest the actors, but then I group by the actor and I just do a count. And then I found out that in my data set, Robert De Niro has the most movies, namely 8. And if we go to Morgan Freeman, we see the number 4 that we saw, or we saw his 4 movies before. But now we see, based on the count, that this really matches. Good. So using these building blocks, let's create a more interesting report or analytical query. And I want to convert my JSON data here. So the data set we loaded from MongoDB Compass was a set or a list of movies, and each movie had an array of the stars. But very often I want to find out, like, given an actor name or actress name, what are the movies that are in my data set? So it's kind of pivoting the data. So again, going from movies which have an array of actors, I want to have actors with an array of movies. So I want to kind of turn the data on its head. And what I do is I use this exact statement I used before, where I project out these actors. So this should look familiar here. This gives us a list of all the actors, but I don't run it the way we ran it before. I basically turn this into a subquery. So I give it a name, and the name I give it is actor title map, because it maps the title to an actor. And then I select from this subquery, and I select the actor, but I add this distinct. So this means don't show a actor name or a star name more than once. So this allows me to get like a unique or a list of actors where an actor is only listed once. So these are all the actors in my data set, and there is no repetition. And now the next step is that I will move this also into a subquery. And let me just copy this in here, arrange the window a bit. So This used to be our select distinct query that we ran down here. I also moved this into a subquery. I gave it the name distinct actors. And now I select from distinct actors, and I'm building a new JSON object. So the SQL language also has SQL JSON operators to build object or arrays. Let's just run this. Maybe it's easier to explain again if people see the query and the result. So what I do is for every distinct actor in my data set, I build a JSON object. This is what you see here. I add this name of the actor, and it has the field name actor. And then there is another field, movies, and its value is another subquery. So you see here movies, and then this subquery builds a JSON array, and it's actually an aggregate, and it's an aggregate of all the titles. So what I do is I go back to my actor title map. There is a join on that actor name, and I extract all the titles and aggregate them inside a JSON array. So you see, for example, for Christian Bale, the movies are The Dark Knight, etc. And now I pivoted this data. So instead of having movies with arrays of actors, I now have actors with arrays of movies. Now this is a query. What I can always do is I can create a view of that query, which basically means I have this query and I give it a name. So the name I give it is called actors movie view. And this is the exact same stuff. Here with the distinct actors. This is where I generate the object. There's a little change here. I'm adding the value for actor. I call this now _ID. And I also add these fields for created and updated, etc. And the reason I do this is that I want to make this view accessible to a collection API or the Mongo API namely. So we see the view got created. So here, if I refresh this on the views, we see this actor movie view. And just to prove that the data is inside, I could run a simple select statement here. We see JSON serialize, and the data column is now a JSON, and it is exactly what we've seen before, the ID, which is the name of the actor and the array of the movies. Good. So now, in order to make this accessible as a JSON collection, I call a utility function. So it's basically a SODA collection. SODA stands for Simple Oracle Document Access API, and I give this collection the name Movies by Actor. And if I go to my JSON page here and I refresh it, there is now the Movies by Actors, and we see how these documents look like. I can also refresh this here. So on REST, let's see what REST tells us. So there's the movie collection, and here's the Movies by Actor collection. So I can also query it using REST. So if I want to know which are all the movies where Al Pacino is a star in, you see here in the small font, it's Al Pacino. I see these results. Or I could go to my Mongo API and, well, let's see, show collections. Maybe the first thing we should now also see like this third collection, Movies by Actor, and I can query it using the same Mongo syntax. And you see we get the document back. These are all the movies that Ben Affleck is a star in. So this really shows end-to-end the capabilities of Oracle Converged database when it comes through JSON. So I've shown you how I upload data through the MongoDB API. I've shown you how I can access it using REST. I've shown you how I use SQL for analytical queries as well as reports. And then I've shown you how I take the result of such query and make it accessible, again, both to REST or to the MongoDB API. So the essence is, with Oracle Database, you can access your JSON data in many different ways. So you don't have to choose between, do I use Mongo API or a collection API for this and SQL for that? Instead, every access pattern is possible. And you can really even combine them. So you could say, for example, I'm using a Mongo API or a collection API to store my application data, but then for my reports or analytical queries, I use SQL. So it's possible to combine these different access patterns or APIs. And that concludes the demo.
So I hope you liked the demo, and let me show you this slide again that I put on earlier. And I hope you understand now what it means that you store your data in Oracle only once, and you have the ability to run both SQL as well as NoSQL style document operations on the same data set. So depending on the problem you want to solve, the workload you want to run, you can really pick what is best for this use case. So an application could insert a lot of orders over REST or Mongo API, and then you can use SQL to do reports on this. So this is really how we can combine the power of SQL with the flexibility of JSON. So all of that you can do today with a 19C or 21C database. Even on like a older database, like a 12 database, you will already find some JSON capabilities. But it doesn't stop here. So our next major release is called 23C. And it adds JSON document relational duality. So this is a brand new concept where you create duality over your relational data. So basically, what does it mean? It means you have data that you store as tables, and then you can define one or multiple JSON views over it. So you can, depending on what your use case is, you can say, I'm picking data from 2 or 3 or 4 tables. I pick the columns that I'm interested in and bring that in a hierarchy that is suitable for my use case. And you can have multiple of these views, and these views are updatable. So you can read and write your relational data using SQL from the tables, or you can read and write the same data using JSON, for example, using REST or Mongo API. And the very nice thing about it is that if you have multiple of these views, they can share the same underlying data. So for example, if you have a JSON object and inside there are some, let's say there is a sub object and it's, let's say, embedded in one view, but it's a top level object in another view, then this mechanism really keeps the data consistent. You make an update through one view and it's immediately reflected in another view. So how would you define this? This is a simple example where you create such a view over relational tables like student, course, teacher, or relational tables. And here we use a syntax that looks pretty much like JSON. It's a GraphQL syntax. And here you can really define how the data gets or how the values appear in your JSON hierarchy in your object. So stay tuned. This is coming in 23C. This is very interesting. If you want to start and take a look at JSON capabilities today, the 19C database is excellent, either on-premise or on the autonomous database. And there are some links here. You can go to GitHub or to our cloud to get a free database like the one I demonstrated. There is our Express edition. And last but not least, we have Live Labs. And I really want to point you to 2 Live Labs that we created. One is for working with JSON and SODA. So SODA stands for Simple Oracle Document Access. These are these collections. It basically shows you, similarly to the demo, how you can combine SQL and these NoSQL operations. Or if you want to set up the Mongo API directly, you can use this Live Lab. If you prefer reading about this information, I suggest you look at the JSON Developer Guide, which has a lot of information about the capabilities in Oracle database when it comes to JSON. And with this, I hope you enjoyed this presentation. I want to thank you a lot. And hopefully we meet each other and I can answer your questions in person. Thanks a lot and goodbye.